be resilient to flooding and drought, downstream flooding or flooding within a project. So for example, drainage can abate flooding if you have, for example, roads that are underwater, but then you move that water from one road and is it going downstream and creating impact to others? So we have to look for both and solutions that manage both these things. It's an imperative given our mandate and our strategic vision at Water Security Agency that this approach allow productive and profitable farms to support the growth targets for the province. And how does this create a robust agricultural sector that supports healthy and thriving communities? So I'm just going to give you some of the information that we learned about this working through some of these demonstration projects. So profitability can increase with agricultural drainage anywhere, and this depends and varies tremendously from place to place and price scenarios and weather conditions and different considerations in terms of profitability. But just as an example, some of the scenarios were showing increases of $40 to $100 in profit per cultivated acre while still maintaining a whole bunch of wetlands. Okay, and so I mean, here's a nice shot of some combines at Arm River Farms, and just I'm going to show you some more data from the Prairie Agricultural Machinery Institute work that was done that shows some of these mechanisms that were previously maybe not entirely understood around these giant increases in profitability that come with drainage. If we're thinking about a robust agricultural sector, we had one of our partner agencies, Saskatchewan Research Council, had an economist from the University of Alberta do some work on increases to total cash receipts at a provincial scale. And again, the dollars vary greatly and depending on the scenarios that are run and all kinds of things. But just to give you a sense of the magnitude, if you considered the total cash crop receipts for 2020, and if you had 30% drainage, 70% of wetlands retained, we're starting to see some pretty big increases in the amount of the total cash receipts. Upwards of 15 to 20% increases possible with development over time. Okay. What was interesting about some of this work is that basically if you work under the understanding that the most profitable drainage will be drained first, as you get to the drainage that's less profitable, you sort of get a diminishing return. So it allows you to start thinking about optimizing agricultural outcomes, profitability outcomes with environmental outcomes. When it came to habitat, basically demonstration projects found that retaining wetlands maintain wetland dependent species, and not surprising that this sort of like working landscape, if you maintain wetland habitat, then it helps maintain some of these species that we might want to retain from a wildlife management perspective. One of the really interesting things, because I pointed out earlier that there's a wide variety of types of wetlands, large wetlands versus small wetlands, more permanent wetlands versus small ones, is that what came out of the research from some of our partners was that small and less permanent wetlands were extremely important for wetland dependent species. When it came to flooding, basically showed that with flow controls and wetland retention, you're able to basically protect infrastructure, downstream infrastructure. So the flow controls reduce the peak flows. As I mentioned, some of the evaluation by Saskatchewan Research Council was able to demonstrate that irrigation projects protect the infrastructure by capturing the water and using it for irrigation. Retention of smaller, less permanent wetlands played an important role in reducing these impacts. And when it came to groundwater recharge, the basic story is that we still don't well understand how we don't understand clearly the impact to groundwater of draining wetlands. It's still unclear. There's of course research has been done, but we still don't really have a clear answer in that. But it might be the small, more less permanent wetlands that may be providing the groundwater recharge compared to the larger ones, the more permanent ones. When it came to water quality, I think it's important to recognize that there's multiple sources of nutrients, for example, that can impact recreational lakes, for example. But when it came to understanding wetlands in the context of our demonstration projects, is that wetland retention reduces nutrient contributions downstreams. The primary function which the pothole type wetlands do this, of course, is that the water runs off the agricultural fields and containing nutrients, and it runs to the wetlands, and it stays in the wetlands because the wetland isn't drained. And so those nutrients just never leave the field. Irrigation projects did the same by the same thing. The water is drained, it goes to the reservoir. That water doesn't leave the reservoir, and so what you have is I'm obviously explaining in a very simplistic sense, but I think everyone can understand the sort of the common sense concept. Then you irrigate with that water, and those nutrients don't go downstream. Where we're at in sort of evaluating cropland BMPs right now is that they're an important potential supplement in combination with wetlands to help address the water quality impacts. So just to dive a little bit deeper into something that's relatively unique that might be really important for some of the folks here, given the audience here, is to understand some of the unique work that's coming out of the Prairie Agriculture Machinery Institute study. So current estimates in the economic literature, and there's a fairly large body of economic literature about what it costs landowners in Western Canada to hold onto wetlands. The numbers in that literature vary widely, as you can imagine, with different price scenarios and production circumstances, this kind of thing. But they don't account for one of the key advantages that's often been reported by landowners. And this is what we call the buffer effect or the bathtub ring effect. Okay, so anyone who's worked in agriculture industries knows that there are some wetlands that there's often a reduction in yield around the outside buffer around the wetland. Okay, so in the picture you see here, so some combine yield data, you can see the red areas of the lower yield responses, and the blue circles you see are wetlands, and the concentric circles you see are 5-meter buffers around that wetland. And so we've all seen this effect, and so that in some instances, but it varies from time to time and place to place. And so some of our landowner partners allowed us access to yield data, which then was relativized by field. So you have to address year effects and field effects. And so yield data was relativized and then examined around the 50-meter buffer around wetlands. And so data was gathered from thousands of wetlands across multiple years. And so basically what the agronomic data did was do an observational study of comparing drained wetlands across these thousands of wetlands versus undrained wetland. So it's an observational study in the sense that there wasn't sort of pre-drainage data and post-drainage data. It was sort of like compared drained wetlands versus not drained wetlands, and then tested for a whole bunch of different effects in terms of wetland permanence and size and these kinds of things. But again, it has to be understood as sort of like a exploratory observational type study. But what was really interesting in this study was that in the black soil zone, this was done with data with both in the black soil zone and in the dark brown soil zone, and similar pattern was found in both. But for example, in the black soil zone, the yield in the 50-meter buffer around the wetland. Okay, so remember we define wetland as by where the soils and vegetation change from wetlands soils to upland soils. There was a 20% increase around drained wetlands as a percentage of field average compared to intact wetlands. And what's really interesting is that this pattern held with some variation across crop types. So in the graph in the bottom right there, what the blue is what the yield in the 50-meter buffer was as a percentage of field average. Okay. And when you compare that to around a drained wetland, what it was as a percentage of field average, you can see some really big differences. So we're looking at about a 20% spread. Not surprisingly, you can see that there's a bigger spread on peas. So again, observational data that needs to be further validated, but leads to some really interesting questions and an understanding of some of the discrepancies in the economic literature around wetland economics that would suggest much smaller values of gains from wetland drainage than some of the landowner reported types of values. So PAMI continued to do some work where they modeled the nuisance effect, which is like, does it take you much longer to perform your operations around the field? The overlap, mechanical overlap, gains in acres, increase in buffer fields. And there's a couple of interesting effects here. One was that variation in construction costs didn't substantially change the economics of drainage. So if you what PAMI did was took the cost of drainage, and it varied in their models, like everywhere from $500 an acre to drain wetland to up to several $1,000s per acre to drain a wetland. And if you put it across all cultivated acres and put it over a long period of time and spread that cost, it didn't change profitability. But what was interesting is that the profitability of drainage was very sensitive to yield response in the 50-meter buffer. It was one of the primary drivers of profitability. Okay. If you take in other potential things, for example, delay of seeding the entire field because of the presence of wetlands and the field being too wet, you can push this profitability up substantially into, like, $100 or more per cultivated acre. Okay. And again, this is extremely context specific in terms of price scenario, specific farm, weather response. So you got to be really careful with these numbers here. But I think the takeaway is that there is a tremendous amount of difference in profitability that can be made with this type of wetland drainage. So just kind of, and these are much higher values than are sometimes reported in the economic literature. One of the other things I want to bring your attention to is that in the wetland, in the PAMI work that was done here as one of our partners in this project, we were reporting the increases as per cultivated acre. Now, this was done because this is often a way that this kind of discussion with landowners is done, as per cultivated acre if you're talking cost of production. Note that in the literature, in the wetland economic literature, it's often reported in changes per wetland acre. Hello? No, that's reported per wetland acre. So while this is some pretty interesting work, I just want to continue to let people know that further experimental work is planned and to validate these things. I don't think any of this is to folks that do a lot of drainage and work in these areas, or people that work in precision agriculture, probably no surprise, but it's not well established or reported in the wetland economic literature. And so I think this might be an important contribution going forward. So just to wrap it up, I just want to get back to this idea of the vision for both drainage overall and for the stewardship policy, that we're looking for, which is this vision of responsible drainage, which is the idea of a working landscapes where landowners continue to use their land for farming and ranching, allows new development while retaining current drainage, but steps are taken in terms of retaining water and other practices, BMPs, to help manage the impacts. And again, understanding that it's really needs to be flexible and adaptive to different regions, like when we're contrasting, for example, the dry Southwest versus Eastern Saskatchewan. If folks have questions specifically about the program, the regulatory program overall, you can certainly reach out to me, or you can email the Ag Water Management email that I show you here, and questions about the program in general or about the stewardship policy that we're consulting on are all welcome. So I'll stop there, and I think we're hopefully kind of on time here to have questions.
Yeah, I haven't heard anything saying we can't have questions. So I'll start off at the bottom here with Sierra's question, has the most thumbs up. But it says, demonstration projects are great to show local regional conditions and variability for that location within that specific year. Is the WSA looking at completing or supporting scientific grade studies that can either validate demo project findings or answer these big agri-environmental drainage questions in the province, such as exploring greenhouse gas emissions, sequestration, groundwater impacts, etc., various ag water management?
Yeah, so I guess a couple things I'd like to. So the demonstration projects themselves, of course, are just important from a practical perspective, seeing what landowners are doing things on the landscape. As a component of that, there was some fairly technical evaluation that was done by some of our partners, as well as some of our works with some of our partners was specifically looking at the literature and applying the literature and giving us technical knowledge based on those bigger questions. So it wasn't all just demonstration, it was also sort of larger scale synthesis and analysis that was done. Now, to Sierra's point, that are there still outstanding questions? And the answer is of course. And so, we're continuing to, invest in work like at the Discovery Farm, for example, and with other partners. And I think that there's a continued need to better understand some of those big questions. A good example is that we're working with Angela Butter-Ardhan at the University of Saskatchewan to work on better understanding carbon changes, soil carbon changes when wetlands are drained. And probably a number of people maybe saw Chantal Chisen's really neat work on this that she presented at Soil and Crops a few weeks ago.
Awesome. There's a comment here from Ross saying there's some recent information from Alberta indicating that producers there do not make more money by draining, but are doing it because of perceived benefits of improved acres. Then just talks about your justification, if that justification of economics is universally valid. It goes off to say the Saskatchewan Conservation Protection Action Plan has drainage-related webinars on their YouTube site. I don't know if you want to say anything to that.
Yeah, so there could be a couple things that are being referred to there. One is some of the work by Galpern out of the University of Calgary, okay, which it could also be talking about a recent paper by Sherry Clare and John Pattison. I can't remember if there's another paper there that looked at about 1 year of data off of 3 or 4 fields or something in the sort of Edmonton area. So you could be talking about a couple different things there. And I think those are both valid studies that are important part of the conversation. It'd be a great side. I don't know who made the comment. It'd be a great side conversation to get into the details of the study and the evidence. And I'm pretty familiar with them. We could talk about them. And with anything, you got to look at all the evidence. But I think it's pretty clear from where we sit that if you look at the big picture of all the different pieces of evidence, drainage writ large makes a tremendous difference to profitability and productivity. It would be sort of still where we would land. But those other studies are valid and they have their little ins and outs that if someone wants to talk about them, maybe get a hold of me and love to have that sort of colleague to colleague technical discussion. Yeah.
Mm-hmm. And then there was a few, there seemed to be a bit of technical issues with the questions coming through. So I don't know if this was from Wally, but it says, what is the full form of the AWM? And that was during what is the full form of the AWM? That was during the stewardship policy portion of your talk there.
So by full form, I'm not quite sure what was intended. You got a sense there, Owen? Maybe you can prompt me a little bit about maybe what they're, so I can better answer the question.
Yeah, it was just during your stewardship policy. That's all I wrote.
AWM, agricultural water management is AWM. I think maybe that's all that was asked. And yes, so the our program writ large is the Ag Water Management Program, or Agricultural Water Management Program more properly. And so we're looking at Agricultural Water Management Program Stewardship Policy, which is basically addressing this question of water retention and wetland retention.
Then we have one from Michael here. Has the WSA looked at the effects of surface land drainage on shallow water tables, biodiversity, pollinators at the section or quarter section level, as well as the effect on terminal water bodies like Quill Lakes?
Yeah. So okay. So shallow groundwater. We had Garth Vanderkamp, who I think most people would know. He's got 5 decades of groundwater research working for Saskatchewan Conservation Development Association, did sort of a review of the literature for us on that. And so certainly there can be observed effects, but there's still just not enough understood about the magnitude and the interrelationship in the data between wetland drainage and surface and groundwater recharge. So that's the first question. I think the next question was around the habitat importance of temporary wetlands. I think so. And so again, there had a number of wildlife biologists involved with the project, and without getting into details, less permanent wetlands are extremely important for wildlife habitat and need to be considered in development of any kind of policy. The next question I think was about terminal basins. So if you drain water into a terminal basin that doesn't have an outlet, that water goes there and can't leave there, and so it has potentially larger impacts than in other areas. So for example, in most closed basins, for example, like the Quill Lakes, WSA is not approving drainage into those lakes right now. That's our approach. So certainly we recognize the potential impacts on terminal basins. Now, the magnitude of it, for example, in specific case studies, it gets pretty complex when you bring into weather, groundwater interactions, and these different things. So that's more case specific. So hopefully I answered that question.
We got one from Laura here. Are inspections or surveys being done to determine if landowners are applying for approvals before making changes to the drainage works? And how might the WSA police this? This is a two-parter question.
Yeah, so...
Oh, sorry, go ahead.
Oh, no, go ahead. Finish the question.
Okay, cool. Since the implementation of the new strategy, how has the involvement of landowners increased or decreased?
Okay. I'll start with the first question, then work my way backwards. As you can see in the graph that I showed, the amount of landowners getting drainage approvals has increased on an annual basis 12 to 14 times over the previous 30 years. So we certainly are getting good support, engagement, and success working with landowners to coordinate kind of things. The next question that's being asked is, I think what's being asked is, are you looking for new development that is occurring? And how are you regulating it and working with those folks to get them in compliance, which is an entirely reasonable question. Our own approach to working with compliance does not prioritize new development over existing development. What we're prioritizing is where there are impacts at a cumulative scale from all development. Okay, so whether it's a new ditch, you might have a new ditch that's being dug that is going into a network that's 150 quarter sections in size, and then there's impacts down at the bottom of that network. So what we're doing is we're prioritizing based on impact, not just new incremental development. So where we're working with people, and there's a variety of ways that we prioritize where we go to work with people to get into compliance. Some of it's if they come in voluntarily, and some of it where there's reported impacts. Where there's these reported impacts, that's where we're prioritizing that type of work. And again, this can involve existing drainage works, often just by how big the network is or where people are reporting impacts. So I hope that answers your question. Rather than chasing after new development, specifically, we're looking at cumulative landscape impacts and prioritizing our working with people to get in compliance in that fashion.
Awesome. And we still have a lot of questions to get through here, so I hope we can still get a break. This one is from Michael. What proportion of the 86% of wetland area that has been retained has been significantly degraded? You know, it's like cultivation to edges or through cultivation in dry periods, eliminating natural wetland vegetation.
Yeah. So certainly some of that 86% includes the drained but not farmed wetlands. Okay. So I would largely what we would consider is the drained but not farmed wetlands are performing the hydrological functions of protecting water quality and abating flooding downstream. But there's an argument, it's like if they don't have natural vegetation in them, are they providing the same habitat value? So there's a valid point there. So there's certainly a proportion of those 86%. I'd have to look that number up. I don't know if that's Michael Champion or not who asked that question. If it is, we can, Michael or whoever can reach out with me. I don't have the number at my fingertip, but there is a proportion of that 86% that is the farm but not drained.
And I saw a request there to ask if you could turn off your screen sharing. I guess that's still on.
Oh, sorry. Yeah, shoot. Sorry. Yeah. Where everyone's seen. Yes, absolutely. Sorry. Yeah, I missed that. You got her. Sorry about that.
Yeah. We have a question from Seth. What do the consolidated wetlands look like? Are they natural, semi-natural?
Yeah, so it really varies depending on the kind of landscape you're in. That example, that one that I showed at Arm River, it's in a deep valley, and so it naturally is going to contain everything. More typically, when we've been designing consolidations working with landowners, is what we'll do is we'll do some hydrology calculations of the amount of water that we expect to go into that wetland. And then we often at the spill point of that wetland, most wetlands will have like a spill point where in a really big flood year where they'll spill out, we often require the landowner to build an additional berm at that point to retain some of the extra water, because we want it to spill only with the natural frequency and amount of water that would have naturally in the absence of the consolidation. irrigation. And so you'll end up building like an earthen berm. Most of them tend to be less than a meter high and say something like 20 or 30 meters long. And so you build them with like, 4-to-1, 5-to-1 side slopes or something. And so it's the kind of work that a landowner can usually do with a front end loader in an afternoon or something, or a piece of equipment. And so you're most often, you could characterize these as a constructed wetland if you want to, because it's a natural wetland with an extra berm putting extra storage on it. And that's in sort of practical terms, these would be the smaller things. It's like less than a quarter section of stuff consolidated kind of thing. If you're going to get into larger kinds of things, it's getting to the point where it's certainly getting into the scope of practice of professional engineers, and then landowners have to get professional engineers involved if they're going to build larger structures.
Right. We have another question from Melanie. What are the salinity issues with drainage? Are the drained lands becoming more saline? Is drainage water saline, or does it impact the salinity of collection ponds? Is the water used for irrigation slow down or speed up the salinization of the land?
Yeah, so there's a bunch of things going on there, and those are all on point questions. So, and it varies a lot. So I'll do my best, and I probably won't sufficiently answer all, but I'll do my best. So, in general, retaining wetlands, and if you're trying to farm in that 50-meter buffer around them, or even into the edge of the wetland, can create salinity issues that impact crop yield. And that's what we saw in the PAMI data. That's part of the equation on that 20%. It's not the entirety of it, but it's part of it. And I think we all recognize that. Anyone who's worked in this field has seen that observationally. It's what landowners report to us. It makes sense. So drainage, constructing surface drains, is often a means to address that. And that's what landowners report. And I think we can see that in the data. When it comes to, can drainage potentially increase downstream salinity? I don't know that we got an entire understanding of the magnitude or the importance of that, or its impact on receiving bodies. Is it potentially there? Sure. I don't know that we entirely understand that. When it comes to irrigation, a key step in the irrigation demonstration projects that we did, and we had a couple of them, was having the Ministry of Agriculture do the soil water analysis to make sure that water was compatible. I mean, a really interesting question would be: you drain 7,800 acres, it goes into a reservoir. Because that's drained land, is that water appropriate for use for irrigation? And in this particular case, it was compatible. In other instances, it wasn't. Actually, Arm River Farms was interested in that large consolidation wetland in doing irrigation out of it, and the soil and the water probably just inherently, not necessarily drained. I'm speculating here, but probably inherently just was not at all suitable, and so irrigation couldn't proceed. So it really varies from time to place. And I think the question also involved like some more nuanced questions about the nature of impacts than I can probably properly address. But I would say those are all valid questions, and they vary from place to place.
Awesome. I'll ask one more question here so we can still get our 10-minute break in. This one's from Mark. How can you protect biodiversity and stream quality if you are relying on landowners to determine which ones are drained? Species indices would be way out of their scope, and water quality could be reduced, which is an important in an ag community, considering all the chemicals that are used in farming.
Yeah. So I should clarify about this one. So what we see at a landscape scale from the analysis that was done using current literature and published literature and this kind of stuff is that the impacts of drainage are largely a landscape-driven phenomenon. Okay, so certainly wetlands and their characteristics vary, especially for habitat and habitat quality for different critters. But what you see is that it comes down to the proportion of wetlands largely that drive it. What proportion of wetlands? And proportion, for example, in water quality is basically proportion of wetlands. Acres of wetlands are a proxy for volume of water stored. Okay, that drives it. So when we're saying that landowners choose, what we're saying is you decide that you need a certain amount of volume or acres retained on the landscape, and you let the landowners do the optimization of where and when those acres are. And what the stewardship policy is saying is, how much of this do we need? Once a regulatory requirement is for how much you need, you let the vision that we're talking about here, nothing's decided, of course, but the vision we're talking about is that landowners drive the selection of that rather than regulatory processes. So, to put it in simple terms, the regulator says, I need so much wetland on the landscape. Landowner, you decide where where that goes. Again, nothing's decided. It's all a consultation. Sorry.
Yeah, no worries. And now that's 10:47. So if we still wanted to have a 8-minute break. I guess this is where we stop. But if Annette wants to chime in and say I can keep asking questions, I'm more than happy to do that. Otherwise, we will take a short break and come back for 10:55. Awesome. Well, thank you.
Yeah, we should take a break probably. Yep.
Perfect. Yeah, let's do that.
All right.
Awesome.
Thank you so much, everyone.
Okay.
Okay.
Take care.
Talk to you again.